Hello, my dear students. This is Amar Hatti, your CAD/CAM teacher. Well, in the last video lecture, we are into your fourth unit, that is computer-aided manufacturing, and we had solved or written the part programming for many operations like turning operations, facing operation, drilling operation, and also I told you to write down the part programming for milling operation also, and that is your assignment. You have to solve, you have to write down part programming for as many as operations as possible. Okay, so by doing so you are going to get a right information to how to write down the part programming for whatever the operations you are going to get in your journey. Okay, so in today's video lecture we are going to start your fifth unit, that is advanced manufacturing method. Advanced manufacturing method. So why we study advanced manufacturing method? Okay, so in this one you are going to study some rapid prototyping techniques. What are the different rapid prototyping techniques, and also the product life cycle and management. So why we study rapid prototyping and product life cycle? To select and apply suitable rapid prototyping techniques for any engineering applications, we study this one. Okay, and also to understand various rapid manufacturing techniques and developing competency in designing and developing products using rapid manufacturing techniques. Okay, so that is your fifth unit. So if we are studying any subject, we have to know what is the syllabus we are going to cover, or syllabus what we are going to study. You have to know that one. Well, the first part of fifth unit is your rapid prototyping. Okay, first part is rapid prototyping. In this one we are going to have the introduction to rapid prototyping. What are the different categories of the manufacturing process, simple or basic steps what we use in rapid prototyping process, and also the advantages and limitations of the rapid prototyping process. Okay, and also the classifications of rapid prototyping technique. Okay, you can call it as process, you can call it as system, or you can call it as technique. Okay, well, there are three different types of rapid prototyping techniques. The first one is liquid based rapid prototyping, second one is solid based rapid prototyping, and the third one is powder based rapid prototyping techniques. And also we are going to study what are the different applications we are going to find about the rapid prototyping techniques. Then rapid tooling, what are STL format, that is stereolithography format, and also the 4D rapid prototyping, that is 4-dimensional rapid prototyping we are going to study in your fifth unit. Well, the second part of the fifth unit is product life cycle. Well, in this one we are going to have the introduction part to your product life cycle management. What are the different components of the product life cycle management, and also the collaborative engineering we are going to study. Okay, so first move to the rapid prototyping, but before going to the introduction to rapid prototyping, you must know what are the different categories of the manufacturing process. Okay, so manufacturing process, once I said you the manufacturing process, what comes to your mind? Well, turning comes, milling, grinding, or whatever the forging, bending, drawing, like these processes will come to your mind. Yes, all those are the manufacturing processes, but how they are categorized, you don't know that one. So manufacturing processes are categorized into three categories. Well, the first one is subtractive manufacturing process. So what is subtractive manufacturing process? Well, in this one, in subtractive manufacturing, the part is manufactured by removing the material from the, okay, well, if I have a material, if I am removing the material from it to get a desired object, then that type of the manufacturing process is called as subtractive manufacturing process. So what are the examples? Well, you worked on lathe machine. Well, you are going to fix the mallet into it, or the workpiece into it, and remove the material which is unnecessarily deposited, and to get the desired object. Well, you can say the examples of subtractive manufacturing processes are turning, milling, grinding, shaping or whatever the operations where you are going to remove the material from the workpiece to get the desired object, then that is called as subtractive manufacturing process. Well, second one is additive manufacturing process. Well, the name itself indicates we are adding the material. Okay, so the object is manufactured by deposition of layers of material into it to get a desired object. So in additive manufacturing, virtually there is no wastage of material, because whatever the material which we need to add, we will add it, and we are not going to have any wastage of the material. So what are the different types of processes? For example, okay, well, the first one is rapid prototyping. Well, that is what your fifth unit deals with, that is rapid prototyping. So rapid prototyping is a example of additive manufacturing process where we are going to add material to get the desired object. Okay, well, the third one is formative manufacturing process. What happens in formative manufacturing process? The forces are applied on a material so as to form the object of the desired shape. Well, in the first one, we remove the material. Second one, we add the material. In the third one, well, only the forces are applied on a material to form the object of the desired shape. So, in which operations we are going to apply the forces? Like if you've seen in forging operation, if you want to bend anything, you are going to apply the forces. If you want to if you are doing a drawing operation, you used a drawing machine, right? Well, in that one we are applying the force to get a desired object. Okay, so your fifth unit is for rapid prototyping, that is your additive manufacturing process. So I already said it is the adding of the material to get a desired object. So how you are going to define the rapid prototyping technique? Well, it is defined as the process of layer by layer creation of any two-dimensional or three-dimensional physical model. Directly the design can be taken from the 3D CAD data. So if I have a 3D CAD data, that may be the two-dimensional or three-dimensional object. If I am making that model by layer by layer, creating the 3D physical model directly from three-dimensional CAD data, then that type of process is called as rapid prototyping technique. So in this one, thin layer of paper, plastic, wax, or stacked one on another to create a solid object. If I am using the plastic, if I am using the wax, what I am going to do? I am just going to pour one layer by another layer to form my three-dimensional object. So why we are using rapid prototyping? Well, you heard about the prototyping. Prototyping means model making. Okay. So let's say that you made a model in your 3D CAD software, and also you are testing it by using the simulation software, right? Well, just imagine you have a chassis. You have a chassis of a car. Okay. So you are doing a force analysis in a simulation software. Okay. But the product behaves differently under actual conditions. Okay, so this may going to vary the results what you are obtaining in the simulation software and in a real case. Okay, and in a real case, so what we need to do is, once we did the testing of that chassis in a simulation software, we also produce a same model and test it in a real time environment, that my product works efficiently or not. Let's say that I have a chassis, I am doing a force analysis, I made a model. Okay, so that model is called as a prototype. Okay, that model is called as a prototype. Prototyping or model making is one of the important steps in a product design. So prototype of a product is made and tested for the performance. If I want to test for the performance, I am going to make it and I am going to test my performance on it. Okay. So let's say that prototyping the product using CAD model and testing it with the help of simulation has its own limitations, because the product behaves differently under actual conditions. Therefore, physically developing a model and testing it for the performance is quite problem in a process of product development. Okay, so manual prototyping by skilled craftsmen is an old practice. If you are going for manual prototyping by using a craftsman, this is a old practice and that is not going to work for it, and also it is a time consuming. Okay, so therefore a simple technique of rapid prototyping is used for creating the physical model of the product in very short time, and that too directly from three-dimensional CAD data. So we are using rapid prototyping techniques. So next part is the basic steps in rapid prototyping process. While prototyping or rapid prototyping technique is classified into three basic steps. The first initial one is the pre-processing, second one is processing, and the final one is post-processing. Well, you can see it in the picture. We have a 3D CAD modeling of the prototype. Then in the pre-processing, we are going to generate a STL file. Then we are checking for the part orientation. Then we are generating the support for the parts. Then checking of STL files will be done after that. Then the transmission of this STL files into some other formats. Then slicing of STL model into thin layers. Okay, so this part is your pre-processing. Then next comes is your processing, that is the part building is also called as the processing part. Okay, and the next part is your post processing. In post processing, we just are going to clean and finish the model, and we are going to get the final prototype of that one. Well, we can go or we will go one by one for this one. Well, the first one is 3D CAD model. In this rapid prototyping process, the first step is your 3D CAD modeling. Okay, it is a creation of three-dimensional CAD model of the prototype or the part what I am manufacturing. Okay, so before manufacturing anything, whatever the process we are following, but before manufacturing we must have a 3D CAD model. So we need to design that 3D CAD model by using any CAD softwares before manufacturing. So the three-dimensional CAD model is created using any 3D CAD package, and corresponding to CAD file is stored into it. So next, what I said, the first one is pre-processing. Pre-processing is normally done on a simple computer which is actually separate from the rapid prototyping machine to save the time and avoid the blocking up of the machine time. So we have a prototyping machine which is completely separate, but pre-processing is done on a separate computer. Well, the first one in pre-processing is your STL file generation. So what is this STL file? Well, STL means stereolithography format, or you can call it as standard tessellation language. Okay, so what happens, let's say that you are designing or doing model or creating the object in a different CAD graphic packages. Like if you are modeling the things in CATIA, well, that is going to save your file into CAT dot some UTR formats. Okay, well, if you are doing the same object in a different software, and it is going to save it in a different format. Okay, so for every changing graphical package there is every changing formats. Okay, so this rapid prototyping machine will not going to accept or different formats. It is going to accept only that is STL format, that is stereolithography format. So whatever the format you are saved, whatever the graphics package you use to model your object, we need to convert that format into STL file format, or we can call it as STL file generation, which is simply conversion of CAD file format to STL file format. Okay, so this STL file format has been opted as the standard file format by rapid prototyping industry. And STL5 format represent a three-dimensional surface as an assembly of planar triangles like facets of a cut jewels. Okay, so the more number of triangles have to be used for highly curved surfaces. So whatever the shape you have, you need to divide them into triangular or planar triangles. Well, you can see it here in the hexagon. We have a hexagon. Okay, so that hexagon faces are converted into the planar triangles. Okay, so if we have a curved surface, highly curved surface, more number of triangles has to be used. Okay, so that is actually the STL file generation. So next part in your pre-processing is the part orientation. So what is the importance of part orientation? So this orientation of part, during the rapid prototyping is very important, because orientation of part is going to affect your prototyping type, prototyping time, prototyping cost, number of layers what we are using to produce the object, and the strength of the part, smoothness of the part, and also the material requirement. Okay, so this is going to affect all these parameters. So in order to reduce the prototyping time and prototyping cost, number of layers, and material requirement, the part should be oriented with minimum height. Okay, minimum height. Well, you can see it here in the first picture. If you want to reduce the prototyping time, prototyping cost, number of layers, and material requirement, the part should be oriented with minimum height. Height should be less in Z direction. In addition, the orientation of part in print box also affect the strength of the object. Okay, the orientation of this part along X, Y, and Z going to affect the strength of the object. So the part is strong if oriented along X or Y axis, and less strong if oriented along Z axis. Well, you can see it here in the second picture, effect of orientation of strength of part. So my part is strong if it is oriented in X and Y direction, and it is going to be weak if it is oriented in Z direction. Okay, so this is about your part orientation. So next is the support generation. We need to generate the support for that one. So in rapid prototyping system, this software allows the automatic creation and editing of support for all the overhang region based on the default support parameter. Okay, well, if you can see it here in the picture, we have a desired geometry, part geometry. Okay, but what if we are not provided this support to the overhanging portion? Okay, so if we are not providing the support to overhanging portions, the overhanging portions may peel away, or it is going to hang itself down. Okay, so that is the common problem due to missing support or overhanging part. So for that, our software, that is the rapid prototyping system software, automatically allows the creation and editing of support for all overhanging regions based on the default support parameter. Okay, so that is about support generation. Next, checking of STL files. So next step is checking for what? Checking for defects, like if we have some gaps in between the manufacturing material, if we have some missing facets, if we are having the overlapping facts, or some triangles are flipped, then that type of defects are checked before transmitting the STL files to the rapid prototyping machine. Okay, so at this stage, defects free STL files are ready for use as input to the next step. Okay, so next part is your transmission of STL files. So this STL file format data is transferred to rapid prototyping computer. Okay, so this data can be transferred either manually or by network. We can transfer it to that separate computer to rapid prototyping machine computer. Next, the final part in your pre-processing is slicing of STL model. Okay, so the pre-processing software on rapid prototyping machine computer slices STL model into a number of layers between varying thickness like 0.1 mm to 0.5 mm. Okay, so the sliced STL model is saved into new file formats like SLC, like stereolithography contour methods, or it will save into stereolithography model also, no worries in that one. And the data which we get after slicing the object is ready for use by rapid prototyping machine. So this completes your pre-processing step. Okay, so next part is your part building, or we can call it as processing step. So once the slice file format data is transferred to rapid prototyping machine by computer, the part building process starts. So depending upon the size and the complexity or complication of the prototype or part, the rapid prototyping machine takes from few hours to several hours for building the part. It will take the time based on the complications of the prototype what we are building. So in this process, the prototype of part is created by depositing the material, like I already said, the polymer or powdered metal, layer by layer from bottom to top. Okay, so the method of deposition depends on the principle used in rapid prototyping machine. And why we are using rapid prototyping machine? Because it is fully automated and the operator may leave the machine on to build a part overnight. If the machine is taking more than 2, 3, 4, 5 hours, the operator may leave the machine on to build itself. And also we have some electronic communication like cellular phones. Once the part building is completed, it is going to inform the user that the part is completed. So this is completely automated. So once the part building is over, the next step is post processing. The final step in rapid prototyping is post processing. So the post processing involves removing the prototype from the rapid prototyping machine, cleaning it, and if any finishing operation is needed, we are going to do that one. Okay, so this completes your basic steps needed or basic steps in your rapid prototyping technique. Okay, so next is we must know what are the benefits we get by using the rapid prototyping system or rapid prototyping technique. Okay, so if you classify it into the benefits, then we are going to have two categories. One, we are going to get the direct benefits, and one, we are going to get the indirect benefits by using rapid prototyping techniques. So what are the direct benefits? If you see like this, we are going to get the direct benefit to design and manufacturing departments. Okay, design and manufacturing departments, we are going to get the direct benefits from rapid prototyping technique. So what are those benefits? So using this technique, the product designer can produce the prototype in relatively short period of time. Well, the time consumption to produce the object by using rapid prototyping technique is very less. Okay, so that is one of the benefit to design department, and also it reduces the cost of making the prototype. It reduces cost of making prototype, so that is also the benefit to design department. And using this technique, the product designer can try different sizes and shapes of the prototype so as to optimize the product design. Optimization in the sense, we are making the lesser size and also we are getting more benefit from it. So the optimization will lead to improvement in the performance of the product. And if you want to increase the complexity without significant increase in the cost and lead time, you can do it by using the rapid prototyping technique. So that is one of the direct benefit to design department. So what is the direct benefits to manufacturing department? Well, the use of rapid prototyping leads to saving in tooling costs, and therefore manufacturing cost of the product is also lower. So that is the benefit to manufacturing department. And also It is an additive manufacturing process. Whatever the material which we need to add, we will add. So that is going to reduce the material waste and waste disposal cost. Hence the material cost is also lower. So that is the benefit to manufacturing department. And in this one, the degree of repeatability of the product is very high. Hence the quality of the product is also better. So that is the benefit to manufacturing department. So what are the indirect benefits? So indirect benefits are benefited more to marketing department and to the customers. So how? So what are the benefits to marketing department? With the use of this rapid prototyping, the production capacity can be varied almost on a real time basis with a notice of very short duration. Okay. Well, if I want to produce a damn lot of products in large numbers, I can produce it in a very less amount of time. So that is benefit to marketing department. And with the rapid prototyping, the new product can be launched in market in very short duration of time. So this is going to make the job of marketing department very simple. So this is also the benefit to marketing department, that is indirect benefit. So what are the indirect benefits to customer? So if we are making the product at very less amount of time with less amount of material, less wastages, then we are going to get the product in a lower prices. So this is one of the benefit to customer. Okay, so the customer gets a product of high and consistent quality also. With rapid prototyping technique, the diversified range of products are available for the customer. Whatever the different type of material he is asking, then we are going to get that one. With rapid prototyping, the feedback of the customer can be incorporated in the product design almost on a real time basis. Okay, so this is about your limitations and benefits of the rapid prototyping technique. If we are having benefits, then we are definitely having limitations also. So what are they? Well, high precision rapid prototyping machines are still expensive and are not economically viable. Well, if you see in rapid prototyping machines, the high precision rapid prototyping machines are expensive and they are not economically viable. And low cost rapid prototyping machines cannot build parts with high accuracy. High accuracy parts, if I want to build, I should go for high precision rapid prototyping machine. Low cost rapid prototyping machines cannot build that one. So the parts manufactured by this rapid prototyping are normally inferior to part manufactured by CNC machine in physical properties. Okay, inferior in the sense they are far more better than CNC machines, like surface finish, strength, elasticity and all. Okay, so this is about the benefits, limitations of rapid prototyping technique. So next is your classification of rapid prototyping techniques. So what are the different types of rapid prototyping techniques we are going to see here? So based on the initial form of the material used, well, if I am using the material, based on that material, the rapid prototyping systems are broadly classified into three categories. The first one is liquid based rapid prototyping, second is solid based rapid prototyping, third one is powder based rapid prototyping technique. Well, I said these are based on the initial material used. So in liquid based rapid prototyping system, the initial material used is in the form of liquid state. Okay, the material is in the liquid state, and liquid used is a simple organic resin that cures or solidifies under the exposure to light. Okay, so that is liquid based rapid prototyping system. Well, we have two different types of liquid based rapid prototyping systems. One is stereolithography and second one is polyjet modeling. Well, in the next class we are going to study what are these stereolithography and polyjet modeling. Well, the second one is solid based rapid prototyping system. Initial material used in this one is in the solid state. So what type of solid states? Well, you can include some wires, some rolls, some laminates, or any type of pallets are come into this one. And however, it does not include powder form in this one. So we have two types. The first one is fused deposit modeling, and the second one is laminated object manufacturing. Okay. Well, the third one is powder based rapid prototyping system. So in this one, the initial material used in this is in the form of powder, is in the powder state, like grain like forms of the material can be used. And we have two types of powder based rapid prototyping system. Well, the first one is selective laser sintering, and the second one is 3D printing. Okay. So today we started your 5th unit. We covered the introduction to rapid prototyping. What are the different categories of the manufacturing process? What are the basic steps in rapid prototyping process, that is pre-processing, processing and post-processing, benefits and limitations of the rapid prototyping, what are the different types of rapid prototyping techniques we studied. So in the next video lecture, I am going to start your liquid based rapid prototyping technique, and we'll have stereolithography and polyjet modeling. Thank you very much. Till tomorrow, have a great day. Bye guys.